In this video, we're going to learn how to transform equations between polar and rectangular forms. The four equations we have used to convert ordered pairs will be very useful here. Now let's recall what those equations are. We had x equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, and tangent of theta equals y divided by x. The two common techniques to help with the process of transforming equations are to multiply both sides of the equation by r or square both sides of the equation. Let's solve some examples to see this in action. In this example, we will be transforming an equation from polar to rectangular form. And the problem states, transform the equation r equals 2 sine theta from polar coordinates to rectangular coordinates and identify the graph. Let's begin by multiplying both sides of the equation by r. So this gives us the equation r squared equals 2r sine theta. Using our conversion equations, we can replace r squared with x squared plus y squared, and we can replace r sine theta with y and write an equivalent equation of the form x squared plus y squared equals 2y. Now this is the equation of a circle. If we complete the square, we can put the equation in the form the quantity x minus h squared plus the quantity y minus k squared equals r squared, where the center of the circle is h comma k and the radius is r. Now, to complete the square for our equation, we begin by subtracting the 2y term from both sides. So we have the equation x squared plus y squared minus 2y equal to 0. Now, since we have an equation which has a quadratic and linear term of the y variable, then we will complete the square for the y variable. Now, I'm going to put parentheses around the y squared minus 2y in my equation that I just wrote, just to remind myself I'm completing the square on the y variable. Now recall, in order to complete the square on the y terms, we need the coefficient of y squared to be positive 1, and it is positive 1 in this case. So next, we will take half of the y coefficient, which is negative 2, and we will square that value. We will add that to both sides of the equation. So we write our equation as x squared plus, and then in the parentheses we will have y squared minus 2y plus the quantity negative 2 over 2 squared. That's going to equal 0 plus the quantity negative 2 over 2 squared. And keep in mind, we need to add the same thing to both sides of the equation. Now, obviously, the square of negative 2 over 2 equals 1. So we can write our equation as x squared plus y squared minus 2y plus 1 equals 1. Now, the trinomial of the y terms that I have in parentheses, which is y squared minus 2y plus 1, is a perfect square and factors as the quantity y minus 1 times the quantity y minus 1. Or in other words, we will write this equation as x squared plus the quantity y minus 1 squared equals 1. And this is the equation of the circle whose center is the ordered pair 0, 1, and radius is square root of 1 or 1. Therefore, we have transformed the given equation in the problem statement to rectangular coordinates, and we have identified the graph of that equation. Now, we can graph polar equations using a calculator. First, we need to change from function mode to polar mode. And on a TI-84, we would first hit the mode key, then the down arrow 3 times. Then we hit the right arrow twice. We have highlighted the word polar, so we hit enter, and this changes the calculator to polar mode. I'm making sure we are in radian mode as well. Now that we are in polar mode, we hit the y equals key and we are in the graphing screen. And notice we have entry fields for equations labeled R1, R2, R3, and so on. So at this point on the first line for the equation R1, we type in the polar equation we were given in the problem statement, which is 2 sine theta. After typing that equation in, we hit the graph button and we're shown a graph of the circle. And here we have the graph of the circle in the viewing window of -6 to 6 on the x-axis and -3 to 3 on the y-axis. And we can observe the center of 0, 1 and radius of 1 we had determined after completing the square on the equation. In this example, we'll be transforming an equation from rectangular to polar form. And this problem states, transform the equation y squared equals 2x from rectangular coordinates to polar coordinates. So let's use the conversion equations that y equals r times sine theta and x equals r times cosine theta to write this equation as square of the quantity r times sine theta equals 2r cosine theta. Now, if we square the left-hand side of the equation, then we can write our equation in an equivalent form as r squared times sine squared of theta equals 2r cosine theta. Now, this is the polar form of the equation, but I would like to simplify a little in an effort to solve for r, see if I can graph this in my calculator. So I'm going to divide both sides by the term r sine squared theta. So on the left-hand side, I divide by r times sine squared theta. On the right-hand side, I divide by r times sine squared theta, and I end up getting r equals 2 times cosine theta divided by sine squared of theta. Now let's recall the original rectangular equation is y squared equals 2x, or x equals 1/2 times y squared. Now this is the graph of a parabola with the vertex at the origin and opening to the right, since the coefficient of the y squared term is positive. Now, using a graphing calculator in polar mode, typing in our polar equation, r equals 2 times cosine theta divided by sine squared theta, we observe a parabola opening to the right in the viewing window of -5 to 5 on the x-axis and -3 to 3 on the y-axis.